Time for some more graphing fun. Here we're looking at square root and cube root functions. So like all the graphing we've done in the past, we're going to kind of have a high level understanding of what we are looking for in terms of each of these graphs, and then we're going to from there follow the same steps every time. So hopefully once we see a couple of these things, it becomes easy to do the vast majority of them. There should be very few that kind of like throw a wrench in our plans here once we have a solid foundation for how to approach them. The first one we're going to look at here is the parent function of the root of x. So looking at this one here, we're basically just saying, okay, if I give you this function, where are we going to start? I start at my origin, which is 0, 0, and then I go up and to the right from there. That's my general form of this graph. We'll talk about how we get the points in a second, but that's just generally what this thing looks like. And I want to have an understanding of why that is. So why is it that I don't have any negative values over here? Well, let's try and plug in a negative value. What's the square root of -1? It's imaginary. It's my imaginary value, I. So since the square root of -1 is imaginary, I basically don't have any real solutions here. So I don't have a graph for this chunk. So as I look at this thing, I'm going to stop at 0, wherever my root gives me 0, and I'm going to continue on with my positive values. So let's plug in some positive squares. The reason I'm plugging in positive squares is because that'll give me nice square roots. So let's say I plugged in 1. The square root of 1 is going to give me 1. That's how I get this point, 1, 1 right here. Let's pick one more nice square value to plug in. Let's plug in square root 4. If I want to plug in square root 4, this is going to give me 2. So I see this point 1, 2, 3, 4 here, 1, 2. So I got a nice point there at 4, 2. If I wanted to plug in an additional nice point, I personally would plug in 9 because I know that it's going to spit out 3. So when we are graphing this thing, it's a little bit different than how we've graphed before. Could I plug in values 1, 2, 3 and see what it spits out? Yeah, I could. But I don't really know what the square root of 2 is. You know, it's 1 and some change. And I don't know what the square root of 3 is. It's, 2 and some change. But I don't know exactly what those values are. So in terms of graphing, it becomes very difficult to graph those accurately. So what I want to do is plug in nice square values. 1, 4, 9. If I wanted to go one higher, I would do 16. So we see this thing ends up sloping very quickly here. Just like our squared values shoot up really fast, these ones are going to creep up slower and slower. So I can see my difference from 1 to 4 here. I've only gone 3 units, but the difference from 0 to 1 was 1 unit. From 1 to 2, I needed 3 units. From 2 to 3, I had to go 5 units, and we're going to keep increasing like that. So now we're looking at a cube root function here. Oops, let's change our colors around so I keep on doing this. There we go. So let's do our cube root in orange. Our square root was in red. Whoopsie. Just to get our colors straight here. So looking at my cube root function here, I want to again start at the middle, 0, 0. For this, there's no horizontal or vertical shift. I'll talk about that stuff later. But when I'm looking at this, I'm going to plug in some nice cube values. So again, let's talk about what my nice cube values are. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. So these are the values that I'd want to be plugging into this function to spit out nice numbers. Now again, with my cube stuff, it can be positive or negative. So I could also plug in -1, -8, and -27 as well. So I'm going to put a little negative as well here. So when I'm looking at these things, let's just plug in 1. If I plug in 1, it's going to spit out +1. If I plugged in -1, it would spit out -1. If I were to go to my next reasonable point, so the next nice point that I can plug in here, I'd want to go all the way out to 8. So I'd be somewhere over here. I'd plug in 8. The cube root of 8 is 2. So I don't know. Let's say my point's like somewhere over here. So this point would be 8, 2. And then likewise, if I were to plug in -8, which I don't know, somewhere down here, be -8, -2. So in terms of plotting these, I again want to choose nice cube values because I don't know what the cube root of 2 is, or the cube root of 3, or cube root of 4. It's just some nasty number that I don't want to figure out. So let's look at the domain and range for these things for a second. So my domain has a restriction for my square root functions, okay? Square root functions, my domain here is just x is greater than or equal to 0. I can only plug in the stuff over here. Cannot plug in any of these values, right? If I plug in -1 or -5 or -8,000, then I'm just going to get imaginary solutions. Here, for my range, since this thing is opening up, I get a range of y is greater than or equal to 0. I'm going to tell you in more detail later on how to find what that range will be, but for right now, we'll just stick with this example for the parent function. For my domain and range for my cube root functions, these are going to be all real numbers. Now it may be hard to imagine because it doesn't seem like this is going up very fast. It's going up very, very slow, even slower than my square root, but this will eventually go to positive infinity off to the right and negative infinity down to the left here. So here I get all real numbers for my domain and my range for the cube root function. Here's what I want to focus on now. This is the more powerful version of both of these things. So in this form, all of the same factors that we see coming up again and again in terms of a, h, and k are basically doing the same thing. And I've got detailed notes below I'll show you in 1 second in terms of what they do. But in a nutshell for right here, a affects the stretch and whether this thing is going to open up or down, aka it would look like a flip here because it's not just opening up or down, it's doing both, so it would kind of flip it. So instead of going down to the left, it would be going up to the left, and instead of going up to the right, it would go down to the right. So that would be my positive negative flip on the a value. Over here it would just open all down. But then my h value again is opposite the way that it looks. So if it looks like x minus 2, it's actually a positive 2 for the h value, so I'll shift it right 2. If it looks like x plus 3, it's actually a negative 3 for the h value, so that'd be left 3. For k value, again, this is just my vertical shift, up or down. And we'll look at a few examples of these in a minute. So again, looking at these graphs, we want to stick with this for my square root, this for my cube root. Now, in terms of steps that they define, they're saying sketch the initial graph with the stretch and then shift either horizontally or vertically depending on what you have for h and k values. I personally don't really like this method just because I think it puts a little too much emphasis on the parent function, whereas we can just take these things and adjust them and go from there. We don't have to keep on doing the first thing to do the next thing. If you want to do it this way, you can, but I personally find it's like kind of, I don't know, it's kind of redundant, it feels like to me. So I don't personally do it this way, but again, if you want to, and then you want to shift HK units, that's fine. You do you. Here is the holy grail of how to graph these things. So this is where all of our information lies in terms of how I recommend us graphing these things. The square root function is on the left, the cube root function is on the right. So as I look at, so this is the split here down the middle. So as I look at my square root function, a determines whether this thing is going to open up or down, whether it's positive or negative. If the absolute value of a is greater than 1, so say for example my a value was 2, or if my a value was negative 2, again it's the absolute value of a that I care about, this thing is going to stretch faster. By faster I mean it's going to go up a little bit faster. It probably won't be like visually noticeable, but it technically is happening. If the a value is just 1, it's just normal. And then if the a value is less than 1, and again, this is absolute, so if I was looking at like 1/2 or negative 1/2, then this thing would be happening slightly slower. So a little bit more gradual in terms of it getting there. The h represents my horizontal shift. If it looks positive, it's going to shift left because that is going to represent an actual negative value. So again, if it looks like x plus 3, it's going to shift 3 left. If it looks like x minus 2, it's actually going to shift right. So again, this is always going to look opposite from what it is. This is why the h is trickier than the k value for most people. The k value is pretty simple. This just affects whether I'm going to shift up or down. So my k is +3, the whole graph shifts up 3. If my k is -2, I'm going to shift the whole graph down -2. So again, when I look at these things, I'm just trying to determine where am I going to start. So how do I figure out where I start? I start by doing this thing here, finding hk. Once I find my hk value, I go to the left and to the right, and I want to pick nice numbers. For a t-chart, for my square root function, I'm going to go 1 unit out and 4 units out, and I'll explain why that is in a second. For a cube root function, I will want to go in both directions, so that's why we see plus or minus here, 1 unit out and 8 units out. And this is because this is what's giving me nice cube roots. This is what's giving me nice square roots. Now you can go further too, like if I want to do 9, 16, 25 here, we could. It's just that that's a lot of graph. And then if I want to do the same thing down here, I want to do 27, 64, 125, again, more than welcome to, it's just a lot of graphing. I wouldn't personally. For my domain, for my square root values are going to be strictly positive. So I can't have negatives here. So I want to set x minus h to 0 and just go up from there. So basically what I'm doing is I'm solving for this value. X is always going to equal h. So as I look at these values, if it looked like something where it was, let's say we got square root of, I don't know, let's do x minus 2, right? I'm going to set this thing, x minus 2 equal to 0, and I solve. X equals 2, right? Which is my h value. So when I'm looking at this, I'm saying, okay, well, this is the lowest value I can have. So from here, my domain, so domain is going to be x is greater than or equal to 2. So that's how I define my domain for these square root functions. My range is going to depend on whether my a value is positive or negative. Okay, so where I'm going to be for my range is from this point, it would be 0 if I didn't have a k value. But depending on the a, it's going to open up or down. So my range is going to depend on this and the k value. So I don't explicitly write the k value here, so I want to make sure I mention it. So for this one, for example, let's just say I didn't have a k value. For my range for this thing, since my a value here is positive 1, I don't see anything out in front, so it means it's a positive 1. My range would be y is greater than or equal to 0, the k. Now let's do one where we actually do have a k value. So let's look at another example. Let's make this 2 root x minus 3. Let's do plus 5. And let's do another one. So we get a couple examples here. Y equals, let's make this -2. Let's do x plus 2 plus 4. Okay, so here I just want to look at my domain and my range. So looking at my domain, again, it's all the values that are going to give me 0 or greater within here. So for my domain, I'm going to get, x values greater than or equal to 3. And then for my range, I want to look at my a value. A value is positive, so I'm going to be above the k. So for my range, I'm going to get y is greater than or equal to 5. So if I plugged in 3, this part would spit out 0. 2 times 0 is 0. 0 plus 5 is 5. That's the lowest this thing is going to go, and then from there it opens up. Let's look at the green now for an example with a negative a value. So here, whoops, I didn't mean to put this under the square root. That was a bit excessive there. Never happened. So when I look at this one here, again, my domain is going to be, keeps on happening. Every time I try and do 2 dots, it just connects it. X values greater than or equal to -2, right? I can plug a -2 in here, get a 0, and that's fine, but I can't go any lower than that. So I'm going to be greater than or equal to -2. In terms of my range, here I want to look at my a value. A value is negative. That means this thing's opening down. So here I'm going to get y values less than or equal to my k value, which is 4. So where I'm looking at my range here, I'm going to be opening down because my a value is negative. Highest I could be is the k value of 4. Here's my parent function for this thing. We looked at this graph before. Again, plugging in some nice numbers, I would get 0, 1, 4, and 9. Let's look at what numbers I would use for these. So I'm going to start with the, I used all different ones. So I'll start out just with the red one. So if I were to make a t-chart for this thing, and now we're plotting points, x and y, I want to start with the first one, which is my h value, so that's going to be 2. When I plug in 2, this spits out a 0. Okay, cool. The next value I want to do is going to be 2 plus 1. So that's where I'm saying this 1 unit out. So 2 plus 1 gives me 3. When I plug in 3, what happens? 3 minus 2 gives me 1. The square root of 1 is 1. I got a nice value. Let's plug in another value. From 2, I want to go 4 units out. 2 plus 4 gives me 6. That's how I'm choosing these values here. So for the 3, it's because I did 2 plus 1. For the 6, it's because I did 2 plus 4. Now, why would I do such a thing? Let's plug in 6 and we'll see. 6 minus 2 gives me 4. The square root of 4 is 2. Oh, that was pretty nice. So again, I get nice numbers that spit out here. If you want to plug in 5, whatever floats your boat, it's not going to be a nice value. So let's look at the yellow one down here. If I were to make my t-chart for this thing, I'm going to try and kind of squeeze it in here. X's and Y's. The first X that I would plug in is my H value, so I'd plug in a 3, right? If I plug in a 3 into this thing, whoops, it's not a very good 3. All right, so if I plug in a 3 to this thing, what would happen? This is going to spit out a 0. 2 times 0 is 0. 0 plus 5 is 5. So the quote-unquote starting point for this thing, HK, is going to be 3, 5. Now let's plug in another point. The next point I want to plug in is going to be 1 more than 3. So I'm, again, moving 1 unit out. So 3 plus 1 is 4. If I plug in a 4, it's going to give me a 1. Square root of 1 is 1. 1 times 2 is 2. 2 plus 5 is 7. Cool. Next one I'm going to do is 3 plus 4. I want to go 4 units out. Whoops. So nothing to do with the 4 here. It's just the 4 being a nice square. So here 3 plus 4 gives me 7. If I plug in a 7 here, it's going to be 7 minus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. Plus 5 is 9. So I get nice y values for these x values. Again, I can fill in the in-between by just saying, okay, graph out my line like that, right? That part I'm less concerned with. The actual points is what I care about. We'll do the last one here in green, and then hopefully you get the point. When we're looking at this one, again, my h value is -2. So I would start out this one. Actually, I think I have some more room down here. So we'll bump this down for our x and y here. So here I got x and y. I'm going to start at -2. Again, I'm going to be going 1 unit out, and I'm going to be going 4 units out. The reason I'm doing that is because it's going to give me nice numbers. When I plug in 2, I don't even have to do this work. I know it's going to be k, I know it's going to be 4. But if you want to plug it in, you can. By plugging in -1, excuse me, -1 plus 2 is 1. The square root of 1 is 1. 1 times -2 is -2. -2 plus 4 is 2. Now when I plug in 2, I get 2 plus 2 is 4. Square root of 4 is 2. 2 times -2 is -4. -4 plus 4 is 0. So now I get my points to graph this line here. The cube root ones actually end up being a lot easier because it's all real numbers for my domain and my range. So when I look at domain and range for my cube root functions, it's all real numbers. I can plug in any x and y that I want. A value does the same stuff. It flips it, and whether it's going up to the right for positive, down to the left for negative, or if it's going up to the left for negative and then down to the right for positive, just depends on, again, whether this thing is positive or negative out in front. From there, the same stretch, normal, or happens a little bit slower applies here in terms of the A values. Horizontal shift is the same. Vertical shift is the same. Pro tip, again, is to pick nice numbers. So here I want to pick easy cube roots. Here we were picking easy square roots. So what I mean by easy cube roots here is I'm going to be focusing on 1 and 8. 1 cubed is 1, 2 cubed is 8. So I'm going to get 2 when I take the cube root of 8, and I'm going to get negative 2 when I take the cube root of negative 8. So I see these values right here. If I want to plug in some ugly numbers, I can do that and adjust accordingly. Again, from wherever I start, whatever h value I get, I'm going to move out 1 unit to the left, and then I'm going to move out 8 units to the left. I'm going to move out 1 unit to the right, and I'm going to move out 8 units to the right. So I'll show you an example. Let's see. I want to make sure we get one of those in. Yeah, we got a good one over here. So that's the gist of my graphing square root and graphing cube root functions. Again, each of them is going to start at hk. I'm going to make a t-chart. The t-chart is going to be a little bit different for my square root things versus my cube root things. And then once I find all those points, I just graph it. Good to go. So let's look at some examples. First one we're going to look at is just how to compare these things. So here I just want to compare this red thing to my parent function. Okay, so this is the whole idea of graph the parent function and then adjust it by your h and k values. Again, if you want to do that, whatever floats your boat. Just make sure that if you are going to do that, you have to include the a value, because that stretch is going to be part of what you need to include in your graph. So when I do this, two things are coming into play. This, which is an h value of -1, again, always opposite the way that it looks, and here I have a k value of -3. So what does this actually mean? So the h value of -1 means I'm going to go left 1 unit, and then my k value of -3 means I'm going to go down 3 units. So from there, I'm good to go. So in terms of how does this graph differ from its parent function, it's going to shift left 1 and down 3. That's it. So let's look at another example here of a square root function. I'm going to do it maybe slightly different than the way that they represent it here, and that's totally fine. So again, for me, I want to start by identifying my a, h, and k values. A value here is -3. H value here is a +2. Looks negative means it is positive. And then I have a k value of 1. Cool. This thing is opening down. My range is going to be my k and then everything less than that. So let's talk about domain and range before we get any further. Domain for this thing is going to be x values greater than or equal to 2. Okay, I'm always going to be greater than or equal my h value, unless this is a -x on the inside, and then it flips the whole thing around, but we're not really doing that level of complexity. So for us, it's just going to be greater than or equal to that thing. So that's going to be 2 for this problem. That's my h value. Then I look at my range. Is my range going to open up or down? A value is negative. That means this thing's going to be opening down. So I'm going to have a range. Y is going to be less than or equal to, and then whatever my k value is, k value here is 1. So there's my domain and range. Now let's actually figure out how to graph this thing. If I want to graph this, I'm going to start at hk. So I'm going to start, at 2, 1. So there's hk, here we got x and y, 2, 1. From here, I'm going to be going 1 unit to the right. So I'm going to go 1 more unit, which put me at 3. Oops. There we go. And then I'm going to go 4 units out. That's going to put me at 6. When I plug in 3 into this equation, what happens? So if I plug in 3, I'm going to get 3 minus 2, which gives me 1. The square root of 1 is 1. 1 times -3 gives me -3. -3 plus 1 gives me -2. That's my y value. Now here, I'm going to do the same thing, plugging in 6. I can write the whole thing out, I guess, because I've just been saying them, but I'll actually write this one out. So negative 3, square root, here's my 6 minus 2, and then I got plus 1, which equals negative 3 times the square root of 4 plus 1, which equals negative 3 times 2 plus 1, which is negative 6 plus 1, which is negative 5. So that's kind of the reason I haven't been writing them all out, is just because it takes up a little bit more screen real estate than I've got. So this one would be 0.6, negative 5. And we see those points here. So as I look at this graph here, they've kind of outlined the first point pretty nicely, but they don't even have the second point here. So I'd be looking for 2 points. So in terms of just adding an additional point here for clarity, so 1, 2, 3, 4, 5, 6, and we got negative 1, 2, 3, 4, 5, and we see that point right here. So that is the second point that we found. And I'd be looking for this point, and this point to have a nice graph. So here we see 3, negative 2, there's 3, negative 2, 2, 1, there's 2, 1. So if you, again, want to start out with the graph and then do your shift, whatever floats your boat. This is how I'd recommend doing it. And this is how I'll expect it on an exam too. So I'll have you fill out a t-chart and then do the graph for it. Here we have a cube root function. So here we're going to outline the important factors of A, which is 3, H value, which is negative 2, and K value, which is negative 1. Again, H value is negative 2 because it's always opposite what it looks like here. It's X minus H. So X minus a negative 2 would look like plus 2. Domain and range is pretty easy for these ones, as it is all real numbers. Oops. So that's good to go. Easy when we get to these cube root functions. And then I want to think, okay, well, how do I graph this thing? So I want to start at HK. So I start at negative 2, comma, negative 1. And I'm actually going to put that in the middle of my t-chart now because I want to be heading 2 units out in both directions. Not 2 units specifically, I'm going to move out 1 and 8 units specifically. So here's X, here's Y, and here's my negative 2, negative 1. So there's my middle point. So now I'm going to represent 1 to the left and 8 to the left. And you're, again, going to see why I'm using these values. So the reason I go 1 to the left, which gives me negative 3, and then negative 8 from the negative 2, which will give me negative 10, is because these are going to spit out nice Y values for us. Here I want to go 1 to the right and 8 to the right. So again, nice cube values. So here it's going to give me negative 1, and here it will give me positive 6. These are the values that I want to be plugging into my function. So when I plug in negative 10, what's going to happen? If I plug in negative 10 plus 2, it'll give me negative 8. The cube root of negative 8 is negative 2. Negative 2 times 3 is negative 6. Negative 6 minus 1 is negative 7. Nice value right here. Let's plug in negative 3. Negative 3 plus 2 gives me negative 1. The cube root of negative 1 is negative 1. Times 3 is negative 3. Minus 1 is negative 4. Good to go. If I plug in negative 1 plus 2 is 1. The cube root of 1 is 1. 1 times 3 is 3. 3 minus 1 is 2. Last one here is I plug in 6. 6 plus 2 is 8. The cube root of 8 is 2. 2 times 3 is 6. 6 minus 1 is 5. We can also notice a pattern here, which is that between all of these nice values that I've selected is my A value, right? Between negative 7 and negative 4 is 3. From negative 4 to negative 1 is 3, is 3, is 3. Is this a coincidence? No, it absolutely is not. So again, this is just a shortcut. Using these nice cubes, we're going to get nice y outputs here. This is what I'd be looking for on an exam, is this full chart filled out in this same format. Again, I'm not looking for you to plug in, 2 points to the left. That's actually like, -2. So I wouldn't be looking for -4 because it's just going to spit out a gibberish answer. I would like -3 because that's 1 to the left. And I would like -10 because that's 8 to the left. Likewise for 1 to the right, 8 to the right. For number 5 here, I mostly just want to tell a funny story, but also just mention how to solve these problems on a graphing calculator. So I don't know how many of you guys have gone to the, whatever the fair that comes around, and, they've got a decent number of rides, and one of them is always a spinny ride. So the last time I went to one of these, my sister went on whatever, rotor, twister, swip you all around ride, whatever the name was, and she yacked on the person next to her, completely covering them, like horrible. Like that's, I think the biggest reason why I don't go on these rides is I'm like, if I get my sister next to me, I won't be the one to puke, it'll be them, and I'll end up covered. I don't want anything to do with that. So when we're looking at actually modeling one of these things, basically it's just giving us some function. So here we're saying the speed is going to be 4.95 times the square root of the, what is this using? Radius here? Yeah, radius of this thing. So basically we get some graph and we're saying, okay, plug in x for your radius. Okay, cool. And we want to see where our speed's going to be 8, meters per second. So we're looking at, yeah. So when we're doing this, I'm basically just saying set this function equal to some value. The way that we do this on a graphing calculator is that one is going to be that set value and the other one is going to be whatever the thing is that we want. So 4.95 times the square root of x. From there, I want to go to my graph and then I'll hit second calc. And then from there, I want to go to intersect. So I'm going to find the intersection of those two things. It's going to pop up a little menu that says first curve. You're just going to hit enter, then it'll say second, and then you'll hit enter again. And then from there, it'll say guess. I don't know why it says guess. TI decided they were just looking to waste trillions of hours of human computing time and forcing humans to click an extra step. So there you go, enjoy that. And then from there, it'll give you the intersection point, which for this one is approximately 2.61. So it would take a radius of about 2.61 meters to get your speed of 8. So just looking at this here, more interested in the calculator bit than anything else, but we won't be doing a ton of stuff like this. It's just good for you guys to at least be exposed to a little bit. Again, same concept here. This one using a cube root function instead, and it's saying, okay, set this thing equal to some value. The value it's choosing is 200. So we end up getting what the average age of an elephant here to be this determined height of approximately 7.85 years. So again, just another example of using the calculator to solve these things. And that's it. So that's all of our graphing, cube root, and square root function stuff. Fun.